Okay, ARE CE 4260. I was just about to email Dr. Dolan saying something's wrong with the interaction diagrams. And I thought, and then I was kind of worried about my spreadsheets not matching. And so I thought I'd better double check. So I went back to what we did. And so this is the work we just did. And I made a rookie mistake. I had this zoomed in and I didn't really check. And so if you look up here, I'm embarrassed to say that this was the 0.9 graph, not the 0.8 graph. So everything we did here was on the wrong graph. Now, in my defense, my eyesight's bad, but and I had it zoomed like this, so I didn't see that picture. But the moral of the story is make sure you're on the right graph. We should have been on this graph, 0.8. So let's redo what we did using the right graph. So let me go back to what we did earlier. Everything up to here is good. It's just I looked on the wrong graph and got the wrong rows. Okay, so we are looking in that first iteration. We tried 0.31 and 0.67 for X and Y. So let's look at the percentage of steel using the correct graph, 0.31, 0.67. I'll make this a little thicker, 0.31, okay, right here, and 0.67 right there. Okay, so that is 4.9%. Okay. 4.9%. Now let's try 0.2 and 0.5 on the correct graph. So 0.2 and 0.5, exactly on the 2% graph. And we'll see that that's exactly what the spreadsheet did as well. But that's exactly 2%. And so obviously I had this thing rigged up. For fun, let's do the 28-inch column. We're looking for 0.25 and 0.57. 0.25. Oops, a little crooked. Let me redo that. 0.25 and 0.57 right there. That looks like 3.3%. It's amazing how different it can be using the wrong graph. So we have 2%, not 1.7%. So 2% on a 30 by 30 column. And I've redone the calculations here. So 2% times 30 squared is 18 square inches. Oh, let me do that again. Is 18 square inches. And 18 square inches, if you remember, was exactly what I typed into the spreadsheet. And so on the spreadsheet, 18 square inches of steel and a 30 by 30 column fell exactly on the interaction diagram. So my interaction diagram matches the ones in the book exactly. And then I mused, I wonder if you could find 18 square inches on the chart. And you know what's funny? If I had just scrolled down here, I included the chart in your homework. So we see that you get 18 square inches for 8 number 14s. And the question is, will half of that, 4 number 18s, fit in a 30-inch column? And so half of them, that's 4 number 14s, needs 17.3 inches width, so it'll fit. Okay, so It's 8 number 14s and 4 number 14s fits. Thankfully, it's a number 14, which is bigger than a number 11, so we still need number 4 ties, so I got that right. And this is wrong here. So the diameter of a number 14, the diameter of a number 14 is, here we go, 1.693 inches, 1.693. Okay, 1.693, I remember that. Hopefully it's still less than 24, and 24 is the correct answer. 1.693. I mean, still greater. That's 27.1 inches. 24 inches is still the least of those three things. So it still is number 4s at 24 inches. Okay. So we have 4 number 14s on each face. Okay, total of 8 of them. And the ties are still number 4 at 24 inches. The last thing we need to check is if the space between the bars is greater than 6 inches, you need to put an extra hoop like this. So let's figure that out. Is the space between the bars greater than 6 inches? So let's blow up the picture of the corner of the column. So you have this. So it kind of looks like that. Okay. And then you got this bar. It's actually kind of big. It's like 1.63 inches in that. Oop, let me get that there. Okay. The cover is 1.5 inches. The diameter of a number 4 bar is 4/8, so that's 0.5 inches. So to the outside of the bar is 2 inches. And we have 4 of those bars, right? So let me try and draw 4 of them. Okay. Let me, not the scale. Oop. Let me try and move that. Okay, that's about right. Copy, paste, something like this, right? So we got 4 of them. And it's 2 inches to the outside, and it was 30 inches overall, right? So from the outside to the outside of these things, okay, that distance here is 30 inches overall, 2 inches on both sides. So that's 26 inches, right? Each of these has a diameter of 1.693 inches. So we have 4 of those, right? Okay. Super handy to be able to just paste them in like this. Okay. Got 4 of those. And so the total gaps add up to 1.693. Okay. This is a lot of work just to figure out if that gap is more than 6 inches. But you got to do it. That's 19.2 inches. There's 3 gaps. Oh, I can already see that's bigger than 6 inches, right? 6.4 inches. So it's greater than 6 inches, which means it's not within 6 inches of a bar that's being held together. So you have to have these extra stirrups. Okay. So I do have this all done a little nicer here. And I found this solution to the problem. And that's when I noticed, hey, I didn't get exactly 2%. And then that's how I figured out I used the wrong graph. But anyway, this is the final answer. And that's what the picture looks like. Okay, ARE 4260. What I want to do now is go over using an interaction diagram now that I have the correct numbers in there. And so remember, I was wondering why this didn't work, why it didn't match what we had done. And I was inadvertently looking at the gamma's 0.9 graph. So let me change gamma to 0.9 here and see what happens. So I'll change gamma to 0.9 and the points inside. So the graph does work. I just was looking at the wrong graph. And so the correct gamma was 0.8. Let me change that back to 0.8. And the points outside. But when we used the 0.8 interaction diagram, we found out we had exactly 2% steel, which meant we needed an AS of 18 square inches. So let me change the AS to 18. And look, we're right in the graph. So this spreadsheet matches both the 0.8 and 0.9 graphs. So everything's good. The graphs in the book are correct. This graph works. And so actually, I should have known I did something wrong when they weren't matching instead of wondering if something was wrong with those graphs. And so there you go. Both the interaction diagrams in the book and the spreadsheet give a 30 square inch column with 18 square inches of steel, which is 2% steel. Okay, that's that. Sorry for the confusion. Okay, so the first thing is, let me get my picture out of the way. So the first thing is I've scanned, let me see if I can make it smaller. So I've scanned all these interaction diagrams. So I have 7 of them. And so they come from different books. So this one here is for a specific combination of f prime c and fy, and there's the gamma, and the key difference in these graphs are the gamma, and gamma is the ratio of the distance between the steel. Okay, just a minute. So this distance okay, the ratio of those two distances is gamma. And these 7 graphs are 7 different gammas, but they come from 2 different books. And so these, the ones that have this in them with the where it cinches in, it looks like a belt that's too tight I would just say a professor that's overweight. So that's what this shape looks like. Okay. That means it has the phi in it already. Okay. But the key thing is when you use these graphs, that's what it is. It's P over AG and M over AGH. Okay. And I've got 3 of these. So gamma is 0.45, gamma's 0.6, and gamma's 0.75. Then I have 4 from the back of the textbook, and this is gamma's 0.6. And these do not have that funny thing down there. These do not have the phi in them. Okay, so they're PN, not phi PN. Okay, so, and the other key thing is that when you look there, it's Pn over F prime C Ag. So there's an extra F prime C in the denominator, but still these graphs are only for 4 KSI and 60 KSI combination. And so these 4 have 0.6, gamma's 0.7, 0.8, and 0.9. Okay, and the main way you use these graphs for design is that okay, so for that graph, which is 4% steel, the main thing is that everything inside that line is safe. So if you have a M and a P that plots inside the line, you're safe. And if you're outside the line, you're not safe. So you get your P and M, you divide by F prime C Ag, and this you divide the M. So you have to remember Pn times E is M. So M over F prime C Ag H. You get your X and a Y. And if it's inside, it's safe. And if it's outside, it's no good. Okay, no good outside, safe inside. And that's basically how we use these graphs. Now, to use the graph, however, you have to divide by AG or AGH. So you need to know the size, but that's the whole point. We don't know the size. So what you have to do, you just have to make a guess and then adjust. Okay, and so if your point is out there, then that would be too much steel because you're over 8%. So if too much steel, that's the percentage, that means not enough concrete. Your next guess, you make the concrete bigger. Okay. If you're in here, you have too little steel, so the percentage of steel is too low. That means you have too much concrete, so you need to make the column smaller. Okay, so you guess, plot, adjust, plot, adjust, plot. The one thing you need to be careful of is as you change the size, the gamma might change. So it just boils down to guess, plot, we'll calculate gamma, right? Find the right graph, plot, guess, plot until you're done, okay? And you have a lot of time because it's take home, but in the past, I've been concerned on a final that if you're a really bad guesser and you spend a lot of time doing this, you run out of time. And so what I spend a lot of time on this lecture is how to make a good first guess. Now, on top of that, I've given you a spreadsheet where you can know the answer within 2 seconds. And so I'll show you at the end how to use the spreadsheet, which I've posted. and this will go really quick. So let's get to the homework. But that's the outline of what we're doing. I took this off of an old final, except I modified it a little bit. In your homework, use the interaction diagrams and then redo it using the spreadsheet. And I'll show you that at the end. Okay. And this homework is due, quote unquote, Thursday. Okay. So here it is. I've got f prime c is 4, fy is 60. I always have to pick that because those are the only graphs I have. You can buy books of these interaction diagrams, but that's old fashioned. Now you can just use the spreadsheet I've given you, and I'll show you how to do that. So I've obviously, I think I've rigged this problem. We'll see how it comes out. I said 1170 kips and 1170 foot kips, and that's not a typo. I was doing something to make the graphs come out, I think. So those are the points. Okay. What we need is a square tied column with row is 2% and the steel is on two faces, like in the picture. And I've said that the distance from the outside to the middle of the column is 3 inches, not 2.5, because these big bars, they have pretty large diameters. And so it comes out more, in this case, it'll come out closer to 3 inches instead of 2.5. And when I say design, I mean pick the size, pick the steel, pick the ties, and pick the spacing. And I wanted to make the column an even number of inches. I think what happened was I had rigged this problem. And so I'm trying to get students to not make as many bad guesses. On your final, I'll take that requirement out. But please, when you make the column, don't make it like 13.75 inches. There you go. Design the column using the interaction diagrams and make sure in a test, when it's time, they said just take 3 guesses at the most. And if you still don't have it after 3 guesses, just call it good. You have a lot of time to do this, so just keep going till you get it right. And so I have a chart here where you can, I need you to, this screen has stopped sharing. Sorry, I'm gonna have to restart this. Okay, so what we're gonna do is, this is the first guess. You're gonna use f prime c is f prime c over 2. This is the equation when there's no moment. So we're going to use that equation because it's the only equation we have that's not from the interaction diagram. But what we're going to do is use f prime c over 2. And the reason for that is this is the equation up here, but we're probably going to have moment. And I'm just guessing it's somewhere down here. So I'm just guessing it's halfway up. And you know, it's just a total guess, the half. Okay, so the equation for the axial load is 0.85 f prime c, the stress, times the area of concrete, plus Fy times the area of steel. The phi is 0.65. You have to reduce the axial equation by 20%, so 0.8. So I'm going to do that and set it equal to Pu. We have phi Pn equals Pu. I'm going to solve for H as my first guess. Or you could just guess 18 inches as a good first guess every time. And you have a lot of time. So, and obviously on the test, on this test, what I did was to make it go faster for them. A good first guess is actually 26, but let's see. I'm not going to give you a first guess on the final, so let's do this. Okay, so we're not going to use 4 KSI, we're going to use 2 as the guess. Okay, the area of concrete, I said try to get 2% steel, so it's 98% concrete. We're trying to get a guess at a first size, so it's h squared is the area. Fy is 60. And it's 2% steel, so 0.02 h squared. Okay, I'm gonna punch out all those numbers. Okay, if I did it correctly, that's what it came out. I'm going to solve for h. Oh no, it gives the right answer. I know the answer is 28. It's a super good first guess. So then you would guess that and you would try, okay? But what I want to do today is show you what to do if you make a bad guess. So we're going to use 26, okay? But this actually worked really well because I've already done it. I know the answer is 28. So that's great if you would do it. But I'm going to use 26 because I want to show you what to do if you make a bad first guess. So we're going to guess 26, okay? The first thing to do is gamma. Okay, I said it's 3 inches to the steel. So can you see the distance between the steel is 20 because 3 inches on each side. And this number is going to tell us which graph to use. Okay. And on the exam, I just gave them the Dolan graph. So they had just 0.6, 0.7, 0.8. You have all sorts of graphs. So I know we had a 0.75 graph. Okay, so anyway. And we had a 0.8 graph. Normally I round down, but I'm just going to use the 0.8 graph. This is your choice. Okay. So we need to get x. So let's look at that graph. Oh, it's the one I really messed up. Let me clean it up. Okay, there we go. Okay, so we're going to use this graph. And the y-axis is Pn over F prime C AG. And the x-axis, remember Pn times Z is Mn, is Mn over F prime C AGH. Okay, so we have to calculate those two numbers before we can use the graph. Okay. Trying to make my U's and N's very different. Okay. For a circular column, phi is 0.75 with the spirals. For a square column with ties, it's 0.65. We need inch kips. Okay, so I have to take mn divided by f prime c times ag times h. And so it's a square, so it's h cubed. Okay, if it's a rectangle, you'd have to be careful. Okay. Okay. So 21,600 divided by 26 squared divided by 26. 1.23. Okay, y is 1,800 divided by 26 squared. And I get 2.66. Oh, and then divided by 4, right? 0.67. Let me make sure I didn't mess that up. 1,800 divided by 4 KSI divided by 26 squared. 0.67. I better double check the M. I think I forgot the 4 KSI. 21,600 divided by 4 divided by 26 squared divided by 26. Yeah, I forgot the 4. So okay. So that's good that I double checked. Okay. I forgot the first time to divide by f prime c. Okay, so we are looking on the graph for x is 0.31 and y is 0.67. Okay, so I'm trying to interpolate that off of the graph. So do this carefully. I see people miscount. That's just outside the 4% line, right? That's the fourth line. So what I'm going to do as best I can I'm interpolating between those two lines. This is just your call. That looks like 4.3% to me. Okay. Okay. So it's too high. I want 2%. So that means you need to make the column bigger. And to make this easier for the test, I said, oh, use even sizes. So your next guess would be 28, 30, 32. Okay. And so this, and you know, I know the answer is 28, but let's pretend you didn't know the answer was 28. So how do you get your next guess? Okay. So what you do, you come from this point back to the middle, and you're really trying to get 2%, right? So what you want is this. You wish you had had this. Oh, that's not quite straight. Let me try that again. So what you really wanted was about 0.48 for the y-axis, okay? Not whatever we had before. So what we want for the next guess what we wanted, let me do it up here. And then solve that for AG, and that's H squared. That'll give you your next guess, okay? And so that says that the next guess is 30. And how this thing works is it always overshoots because it's sort of like you're taking a tangent and you're extrapolating. So what I do is whatever the next guess is, I average it with the original guess to make my real next guess. So I had 26. I thought it's 30, but my experience is it always overshoots, and then you keep going back and forth, and then this one will be too big, and then the third time will be just right. It's like Goldilocks. Too low, too high, just right. So you could guess 30, and I could tell you already it's going to be too big. Then you say, oh, it's 28. So I'm going to, oh, you know what? So I'll show you what happens when you guess too big. So we'll do 30, which is wrong. The answer is 28. So, but what I would do, well, you're not in a time crunch, but on an exam, if the next guess was 30, I would average it with the original guess to get 28. But we'll just do 30. Okay, so we'll do 30. And I'm predicting the future, and then 28 will be just right. But okay, let's try 30 just so you can see what happens if you guess too big. Okay, so 30. Three inches on each side, so the distance between the steel is 24. So we will use the 0.8 plot. Oh, maybe this actually will work. Okay, so let's get the X and the Y. Let's see. So X is MN which was 21,600 divided by 4 divided by 30 squared now. Divided by 30. Okay, y is 1,800. Okay, I'm going to double check those. 21,600. Yep, 0.2, 1,800, and 0.5. No, those are correct. Let's check it on the chart. 0.8 chart again. 0.2. Oh, I'm going to have to eat my words. Oh. Okay, again, I'm extrapolating. That looks like 1.7%. That's pretty close, but let's try 28. $25 to 57. So I take it back. I guess the 30 was the best guess. Okay, so 30 was the closest, 1.7%. So I'll pick 30. So okay, so we need to find an even number of bars that has 15.3 square inches. Oh, this one doesn't have the big bars on it. So I'm going to have to, I've got it on my computer. Just a minute. So we're looking for 15.3 square inches, an even number of bars. So 4 number 18s. Oh, where's my pencil? A number 18 is 2 square inches, 4 square inches. It's 2 by 2. It's equivalent of a 2-inch square rebar. Okay, so 4 number 18s. Okay. It's 2 per side. That obviously will fit. Okay. The ties. Okay, so if you remember, let me get you the slide. Um, okay, if it's number 11 or bigger, it's 48, it's number 4 ties, and it's 16 times the diameter of the long bar, 48 of the tie or the minimum thickness. Okay, so 16, 48, and thickness. So it's number 4 ties because it's bigger than 11. Okay, so a number 4 is a 1/2 inch in diameter. Okay, so 16 times a 1/2 inch is 8 inches. Okay, 48, sorry, 48 times a 1/2 inch is 24 inches. A number 18 bar diameter is 2.257. And that's it. The least of these three. So number 4 at 24 inches. And there you go. Okay, so we have 5 minutes left, and let me show you how to use the spreadsheet. Okay. So I've posted for you. Let me see. Okay, just a second. So I posted for you this spreadsheet. And here, what you do is you type in the MN and PN you're designing for. Okay, so we had MN was 21,600 inch kips. And we had PN was 1,800. Okay, so that's this point here. I'm going to delete the other two. Okay. And so I made this spreadsheet so that you could check as many columns as you wanted, and it was supposed to be for your project. Okay, so there's the interaction diagram, and there's the point. It's obviously too small. So right now, this is a 16 by 16 inch column with F prime C is 3. So first of all, I'll change that to 4. There you go, it's better. And so let's put in our first guess of 26 by 26. And we had, for an amount of steel, we were guessing of 2%. I'm going to put in 2% of that. That's 13.5 for the total steel, roughly. So that was too small. Okay. So I'm going to put in our final answer of 30 by 30. Gamma was 0.8, and the amount of steel was for number 10, 18s was 16 square inches. So according to our interaction diagram that I made, that will not work. Okay, and yeah, so I've never checked the interaction diagrams that are in the textbook. So I need to talk to Dr. Dolan about that. And then this does come out to 1.8% steel. So yeah. So 24 is gamma, right? That's right. Yeah. So I don't know. So if you're using this, what I would do is probably go to 32. And then that works. And that's 1.5% steel. Okay, so to use a spreadsheet, all you do is you just change these numbers until that point comes inside. Okay. Let me make sure I type those numbers in right. 21,600 and 1,800. Yep. But that's all you do to design it using a spreadsheet. So according to the spreadsheet, it would be a 32 by 32 with 16 square inches of steel. And that's all you have to do for this. Type in the points here and just change these numbers until the red dot is inside the graph. And then just take a screenshot of this and it's good. Okay. Okay, so that's kind of interesting. I'll send an email to Dr. Dolan about this, ask him what's going on. So, you know what it is? In my interaction diagrams, I take into account the actual, where the steel is, the concrete is missing. There's like a hole where the steel is. So I take out that strength of that, and it makes my graph smaller. And so I'm pretty sure the graphs he has doesn't do that. And so Yeah, it's kind of scary, right? It's like, you just use those graphs, just assume they're right. But that's why we have safety factors. But that's pretty interesting. Okay, there you go. So you will get different answers from the spreadsheet and using the graphs. And but this is super handy to have, this little spreadsheet. You just, I started at 8:54 or 10, yeah, so 10:44. Yeah, it took me 48. Anyway, it took me about 5 minutes to do this. I'm not using Excel. So this also could be a way for you to get a good first guess. Just use this spreadsheet. Okay. There you go. Just make sure that you get the MN and PN correct units. Make sure it's in kip inches and kips. And make sure you divide by the phi of 0.65 before you type it in here. And this will work. Okay, that's that. I have posted this spreadsheet and all the interaction diagrams for this homework. Okay, so you've seen the answer. The answer for the homework is a 30 by 30 according to the graphs. I'll post that later. And this spreadsheet, you're going to have to change it to 32 by 32. Yeah, you could probably you could do a 30 by 30 with more steel. Oh, look at that. If you could get 18 square inches of steel, that'd be perfect. So I don't know if you can find 18 square inches of steel on the chart. So 30 by 30 with 18 square inches is perfect. That would work. Okay. So anyway, just whatever. I don't know if you can find 18 square inches of steel off the chart, but there you go. That would work. And so for the project, what it was going to be, you just type in like all these numbers here. And because I was going to make you use one size column, you put everybody's columns would go in here. And just make sure all the dots are inside, and then that was it. That would all you would have to do. The hardest part of this is actually getting the moment for the columns, because you have to do a structural analysis. Okay, but there you go. That's how to use this spreadsheet. And it's pretty handy. Stop the share. So the answer that I got using the interaction diagrams for the book is 30 by 30 with 16 square inches, and using the spreadsheet, 18 square inches of steel. So what we'll do the last 2 days, I'll post an old final, and we can just walk through the old final. I've been asked, when's the last day to turn in your homeworks? I'll say the Monday after the last day of finals. And the final will start on Wednesday, and I'll give you to Friday midnight to do the final.